Welcome to conditional statement if else. Conditional statement if else. We discussed it in the last session about the control structures, how these controlling of statements is supported by the C language. So we discussed about sequencing, we discussed about selection, and we discussed about repetition. And we discussed in detail about sequencing, and then the use of goto, which results in what is called as unstructured programming. So to avoid it, we have what is called as conditional statements. So these conditional statements are supported by the C language in the form of if else, and also in the form of switch statement. There are two different statements. In this session, we will discuss about if else, how the execution of statements is controlled using a condition, or conditional statements are those which permit the execution of statements based on some condition, whether that condition is satisfied or not satisfied. If statement is a conditional statement that is supported by the C language. The general syntax of if statement is if expression statement 1. If expression statement 1. What does it mean? If expression statement 1. If expression statement 1 means, so the expression is evaluated. So if the value of the expression is true, then statement 1 is executed. Otherwise, statement 1 is not executed. Again, the statement 1 can be simple statement or compound statement. Simple statement, that is just a single statement. Compound statement means a set of statements or group of statements enclosed in flower brackets. So if the value of the expression is true, then statement 1 is executed, otherwise it is not executed. Okay, that means if the value of the expression is false, then statement 1 is not executed. Now, what is that being true or false mean? So in C language, whenever an expression is evaluated, any value other than 0 is considered as true. If the evaluation of the expression results in a value other than 0, then it is considered as true and statement 1 is executed. If the value of the expression results in 0, then statement 1 is not executed. So if the value of the expression is true, then statement 1 is executed, otherwise it is not executed. So that is the first basic form of if statement. Next extension of it is if else statement. Now we discussed that if the value of the expression is true, then statement 1 is executed. If the value of the expression is not true, then statement 1 is not executed. But what we want to do is, if the value of the expression is true, then okay, you execute some statement. Otherwise, you execute some other statements. Otherwise means if the value of the expression is false, you execute some other statements. So that is supported using the if else form. If the value of the expression is true, then statement 1 is executed, else statement 2 is executed. If the value of the expression is true, then statement 1 is executed, otherwise, that means if the value of the expression is false, statement 2 is executed. So if the value of the expression is true and if statement 1 is executed, after that what happens? Where the control goes? Say here you have, say, S3. So if the expression is true, then statement 1 is executed. After that control goes to statement 3. That means after executing statement 1, go directly to statement 3, that is S3. So if the value of the expression is false, then statement 2 is executed. Statement 2 is executed. After that, again control goes to statement 3. Statement 3. So if the value of the expression is true, then statement 1 is executed. After that, statement 3 is executed. If the value of the expression is false, then statement 2 is executed, and then statement 3 is executed. So that's how this if else statement works. So you have two choices. If the value of the expression is true, you do something. If the value of the expression is false, you do something. Next, nesting of if else statements. Nesting of if else statements. Nesting. What do you mean by nesting? What do you mean by nesting? Okay, here we are saying if expression is true, then statement 1 is executed. Statement 1 is executed, or otherwise statement 2 is executed. What if statement 1 is itself another if statement, or statement 2 is also another if statement? So that is nesting. So if expression 1 is true, then you go to the next statement, that is execute the statement. That statement is if expression 2 is true, then execute S1, else S2. Else S2. That means if expression 2 is S1, expression 2 is S1, expression 2 is true, then S1. This is actually nested within the statement, if expression 1. So this is the nested statement. This is the nested statement. This is the nested statement. That means this is within this statement. So here how it is executed? If expression 1 is true, then if expression 2 is true, S1 is executed. If expression 1 is false, then this statement is not executed. Okay, there is one twist here. We'll discuss it in the form of dangling else. At the end of the session, we'll discuss dangling else. But point to be noted here is if expression 1 is true and expression 2 is true. If expression 1 is true and also if expression 2 is true, then only S1 is executed. If expression 1 is false, S1 is not executed. If expression 2 is false, then also S1 is not executed. So this S1 is executed only if both expression 1 and expression 2 are true. Multi-level if statements. Okay, we have seen if expression 1 is true, execute say S1, else execute S2. Can you extend it? You can. In C language, you can extend it. So this is the general format. If expression 1 is true, then execute S1. Else if expression 2 is true, then execute S2. Else if expression 3 is true, then execute S3. Else if expression 4 is true, then execute S4. Else execute S5. So how it is working? If the value of the expression 1 is true, then S1 is executed. After that, control goes to outside the loop, outside this if statement. So if expression 1 is true, then S1 is executed. After that, control goes to some statement, say some S6. Assume that some statement is there, S6. So control goes to that statement. If expression 1 is true, then S1 is executed. After that, it goes out of the if statement. So whatever may be the statement that is present after the if statement, that is executed. If expression 1 is false, then expression 2 is evaluated. If the value of the expression 2 is true, then S2 is executed. If the value of the expression 2 is false, then this expression 3 is evaluated. So if the value of this expression 3 is true, then S3 is executed. If the value of expression 4 is true, then S4 is executed. Otherwise, S5. So if the value of the expression 1 is true, then S1 is executed. When S2 is executed, if this is false, expression 1 is the expression 1 is false, and if expression 2 is true, then S2 is executed. When S3 is executed, if expression 1 is false, expression 2 is also false, expression 3 is true, then S3 is executed. If expression 1 is false, expression 2 is false, expression 3 is false, and if expression 4 is true, then S4 is executed. So if all these expressions are false, then S5 is executed. Is it okay? Then expression 5 is executed. So here the order of the statements is also important. Order of statements is also important. Okay, because suppose expression 2 is true, expression 3 is true, and say expression 4 is also true. Then in that case, which one is executed? So the first one that becomes true is executed. So if expression 2 is true, then this is executed. This will not be evaluated. This will not be evaluated. Okay. So after expression 1 is true, S1 is executed, and then control goes here. Similarly, if expression 2 is true, this is executed, this is executed, then control again goes to S6. Okay. So like that. Here S1, S2, S3, S4 are executed depending on which of the expressions, that is expression 1, expression 2, expression 3, expression 4 is true. Otherwise S5 is executed. If more than one expression is true, then only the statements in the first expression which is true are executed. Okay, that's how this multi-level if statement works. Multi-level if statement works. This example, we'll discuss programming part also, but for the time being, just consider this example. What is happening if A equal to 1? Remember the double equal to here, double equal to is comparison operator in C language. Double equal to is comparison operator in C language. If A equal to 1, then first statement is executed. Else if A equal to 2, then second statement is executed. Else if A equal to 3, then third statement is executed. Else otherwise statement, that is printf prints the otherwise statement. Otherwise statement. Dangling else problem. So observe it carefully. May not be present in many textbooks. What exactly is the dangling else problem? Dangling else problem. Here you can see if expression 1 is true, if expression 1 statement 1, if expression 2 statement 2, else statement 3. Okay. Now there are two ifs and then one else. Now the question is with which if this else is associated with. Else is associated with. Is it associated with this if or is it associated with this if? Or otherwise, in other words, what is this statement? If expression 1 is true, if expression 1 statement 1, if expression 2 statement 2, else statement 3. How do you interpret it? Where do you place it? Where do you place it? You move it like this and you make it part of it and associate this else with this if, or you associate this else with if. This is called as dangling else problem, and the solution is, the general solution is, the else part is associated with the nearest if. That means this else will be associated with the else will be associated with this if, else will be associated with this if, the nearest if. So that is the solution. That is the solution. So sometimes it may lead to confusion. That's why we discussed this dangling else problem. So better you use these flower brackets so that there is clarity. In case of any ambiguity, use those flower brackets. Okay, this is regarding the discussion, theoretical discussion of this if statements, different forms of if statements. Okay, note that in life everything is conditional, so try to use these conditions to go according to the conditions. Nothing is free, everything is conditional. So we'll go to the programming example. We'll go to the programming example. We'll go to the programming example. Okay, we'll go to the programming example. Okay, otherwise start a new file, go here, press new file is created. Better you save it immediately. Save it to some folder which you have created. I'm choosing just downloads. You can create your own folder in Windows or Linux, and then you can save it. Okay, here I am saving it to some downloads folder. So include stdio.h integer main. This all we have already seen. This skeleton is required. We discussed that in some IDEs here you have to write void main and then return 0 is not mandatory. So but here this is the skeleton. Let us check. So type of errors correct. Save it as .c file. That will not get confused. Okay, save it as .c file. Okay, there are no problems with this one. Now let us go to if statement. How do you use if statement? One simple example. If say a equal to 1, printf of a 1, and print like this. Okay, what happens? Let me build. There is some mistake. What is that mistake? A undeclared. Undeclared. I am making use of a, but I have not declared it. So what I have to do? Declare it. Declare it. And I am checking the value of a also. That means some value you have to read. Some value you have to read, or at least a should be initialized. A should be initialized. So I will read it. I will read it. Say printf enter the value of a. Okay, scanf Ph.D of A. Okay, let me check. No issues. What is happening here? So I've read the value of A. I've read the value of A. Now, if the value of A is 1, then this statement will be executed. Otherwise, it will not be executed. Let us run it. Okay, enter the value of A. So I give it as 1. You can see the value of A is 1 is printed. The value of A is 1 is printed. I will run it again. Now give it as 2. So here you can see nothing is printed. That means when the value of A is 1, this statement will be executed. Otherwise, it will not be executed. Control goes to this point. Control goes to this point. Okay. Control goes to this point. Now, one point you have to remember is, or one mistake that is commonly done, and which is a logical error, which sometimes difficult to find, is instead of using double equal to, people will use equal to. Now what happens? I told you one point. In C language, anything other than 0 is true. In C language, anything other than 0 is true. Now let us check it. Okay. Compilation finish. Value of A 1. The value of A is 1. Fine. Fantastic. Okay. Now let us run it again. And let me give again 2. In the previous case, what happened? Nothing happened. But here you can see the value of A is 1. This statement is printed again. This statement is printed again. Even though I am giving the value of A as 2, this is printed. Why? Why means because you have not used double equal to, you are not comparing, you are assigning. Whatever may be the value of A, you have read here, doesn't matter. What you are doing here, A is assigned the value of 1. That means always A gets the value of 1. Now 1 is true. That means this is always true. This becomes always true. So this statement is executed. This statement printf is executed, always executed. So be careful. Single equal to is assignment operator. Double equal to is comparison operator. Double equal to is comparison operator. So always use double equal to. Now let us expand it. So L spot. Let us add the L spot. So the value of, say, value of A is not 1. Let us call it as. You can write any statement. Okay, you can, in fact, you can group the statements also. So maybe good programming practice, you can always enclose these statements, flower brackets. This here also. Whenever you want to use single statement or multiple statements, better you enclose them in flower brackets. F. Okay. Now let me run it. First compile it. It's compile, execute. Value of A is 1. So the value of A is 1 is printed. Okay. So in the previous cases, before the use of this else statement, what has happened? If A value is not 1, then nothing happened. But here we are, if the value of A is not 1, then we are trying to print it. So let us execute again and give the value of A, say 2. Means A value is not 1. So if A equal to 1, no. Else, what we have to do? The value of A is not 1. So that means here, when the value of A is equal to 1, this statement is executed. Otherwise, the value of A is not equal to 1, A value can be 2, 3 or whatever it be, in that case this statement will be executed. This statement will be executed. So that is if else part. That is if else part. Okay. Now what we can do, we can expand it. We can expand it. Okay. Again, just as for simplicity's sake, let us consider it as else if A equal to 2. Okay. Print up the value of A is, let us print it. Just modified it. Instead of printing it as 2, 3, etc. Let us print the value. So else if A equal to 3, if value of A is of A is 3, or otherwise else printf the value of A is say not 1, comma 2, comma 3. Print it like that. Okay. Let us compile it. So execute it. First, let us give the value of A as 1. Okay, the value of A is 1. Fine. Next, let us give the value of A as 2. What happened? The value of A is 2. So the correct statement is executed and correct value is printed. So if the value of A is 2, so this is printed. Value of A is, what is the value of A? That is 2. The value of A is 2. So remaining 2 cases also. 3. Value of A is 3. Fine, fantastic. Next, value of A is say 4. So the value of A is not 1, 2, 3. So similarly can give any value. Okay. But you have to give integer value. So the value of A is not 1, 2, 3. So that's how this multiple if statements work. So depending on your requirement, you can use any number of else ifs. Any number of else ifs. Okay. Any number of else ifs. So if you have only one condition, fine, you can use if statement. If you have two conditions based on which you want to execute two different statements, then go with if else. If you have multiple conditions and you want to evaluate them, and based on that one you want to execute only one statement, then you go with if else if. You can say if else if. Okay, this can go to any level. This can go to any level. You can have any number of else if statements. At the end you will write else statement. Okay, so this is the correct way. Now let us experiment. Let us experiment. Just play with it. Now what I do is I will keep this as 2 only. Now which one is executed? I will build it. Okay, I will execute it. Now I will give the value of A is 2. What has to be printed? What has to be printed? So the value of A is 2 is printed. The value of A is 2. This statement is printed actually. This statement is printed. 2 because in both the cases 2 is printed. I am just changing it. Value of a, I will call it as the value of a 2. Okay. Now if this is executed, it should be printed as the value of a2. If this is executed, it should print the value of a is 2. Now which one is executed? Or will it result in execution of both? 2. The value of a2. That means this is executed. This is executed. So the first condition that is satisfied will be considered and the corresponding statements will be executed. Okay. So that means sequencing is followed here. Within selection also sequencing. Okay. Sequencing is followed. Now let us try to remove this one. I too don't know what exactly happens. Let us see. Is else compulsory or not? Let us check. So it's not generating any error message. Okay. It's not generating any error message. So else is not mandatory. You can skip it. Else is not mandatory. You can skip it. So like that you can experiment. You can do the nesting also. Now let us modify it. I'll remove this one. So if a equal to 1, a equal to 2, okay, then this statement is executed. Okay. Else if it just call it as test statement. Now will this statement be executed? Is there any chance for execution of that nested statement? Just check it. What we are saying, a equal to 1, and then within that one again we are checking if a equal to 2, then nested statement. Otherwise, no. Let us build it before we go into the discussion. Compilation, no problem. A is 1, say the value of a is 1 printed. The value of a is here. This one is printed actually. The value of a is this one is printed. Okay. Next 2. So nothing is printed. 2, nothing is printed. Please note down, when I am giving 1 as input, what is printed? What is printed? I will run it again. That is the value of a 1. So the value of a is 1 is printed. The value of a is 1 is printed. Okay. The value of a is 1 is printed. Note down that one. Now when I give value of a as 2, nothing is printed. I give the value of a as 3, nothing is printed. So here the point to be noted is this nested statement, printf nested statement. This will never be executed because we want the value of a, we want the value of a to be 2 also, 1 and 2. Both cannot be true, so this will never be executed actually. But another point to be noted is this else is associated with this if. Else is associated with this if. Okay, this else is associated with this if. Else is associated with this if. This else should be associated with the nearest if. Nearest if. So if the value of if is 1, if the value of a is 1, a equal to 1, so it goes here, and then it checks the value of a as whether it is 2 or not. If it is 2, this would have been executed because this is 1 only. So this, because this else is associated with this if, because this is false. So because this is false, else part is executed. That's why we are getting the value of a is 1. Okay, it is something like should be like this. So the value of a is 1. Okay, fine. Then it checks the value of a again. If it is 2, this statement would have been executed. So with this, it cannot be both 1 and 2, so this statement is never executed. And then if the value of a is 1, true, the value of a is 2 is false, then this statement is executed. So this else is associated with the nearest if. Is something like as if we have written this in this form. So if a equal to 1, then it goes inside this statement. Otherwise, it will not go. Say if the value of a is say 5. What is happening? Nothing is happening. The value of a is 5. This is false. So this is false. So it goes out. Here control goes to this point. So if this else is actually associated with this if, then if the value of a is not equal to 1, then it would have been executed. But here what is happening? This else is associated with this if. So in simple terms, it is little confusing to you. In simple terms, what you have to remember is the else part is associated with the nearest if. Else part is associated with the nearest if. Okay, that is regarding this statement. What else we can try? What else we can manipulate? So we can extend it. By making this condition more complex. You can use 2 or more conditions. Here now only one condition. Now let us try to write a program. Where the value of a is based on the value of a and b, something is printed. We are taking 2 variables, a and b. So we'll assume that the possible values are 1 1, 1 2, 2 1 and 2 2. Okay, let us try to write it. Let us again expand it. So let us have another variable b, and let us read the value of b also. Set the value of b. Scanf %d of b. Okay, you are reading it. A equal to 1. And b equal to 1 and b equal to 1. Then what you do? Print, just print values of say a and b are 1 and 1. Let us directly print it. Like this. You can have nested condition. You can have multiple conditions. Let us try it. Let's build it. Check. So fine. Now when this is printed, when only both a and b are 1. Let us check it. Let us first give the value of a as 1 and also b as 1. So the values of a and b are 1 and 1. Okay. Now if suppose I give the value of b as 2, then what happens? A equal to 1, that is true. B equal to 1, that it becomes false. So this works like this. I think we discussed it previously also. So this is logical AND. This whenever you have logical AND, they try to the table. So let us first complete it. I will try to draw the table also. A equal to 1, B equal to 1. If both are true, then only this statement will be executed. If one of these is false or if both are false, then this statement will not be executed. Let us give some other output. Okay, execute. So A has 1, B has 2. So then this statement is not executed. Let us give both 2, 2 or 2, 3. Both 2, 3. Let us give this 3, say this is some 5. Then also it is not executed. So what is this? Logical AND, how it is executed? Try to write. So this is like this: expression 1 and expression 2. Say if expression 1 and expression 2 are there, then if the value of the expression 1 is true, the value of expression 2 is true, then the net result is true. Then the net result is true. Otherwise in all the remaining cases, that is say false, say true, that case it is false. So if this is true and if this is false, that case also it is false. If the value of the expression 1 is false, if the value of the expression 2 is also false, then the value of the expression 1 and expression 2 is false. So this will be true only if both are true. that is logical AND. So you have logical OR also, which we generally use. AND and OR both will be using. In that case, in the case of logical OR, this is AND. Okay. This is if when you are using AND. If this is OR, which is represented as this double line, vertical line. In that case, true and true, it will be true. Okay, true and true, it is true. Small letter or capital letter doesn't matter. Okay, so this will be true. And if it is false true, in that case, if one of it is true, then also it is true. So if one of it is true, then it is true. It will be true. Again, both are false, then it will be false. So you can combine multiple conditions. So like that you can add. So this is regarding if-else statement. So please try to understand these control structures perfectly. There should not be any ambiguity. So because every program which you are going to write, you are going to make use of control statement or control structure. Every program you are going to make use of this control statement. So this is if statement. The remaining ones we'll discuss in the coming sessions.